Term structure and risk structure of interest rates. This is chapter 6. Following are the learning outcomes from this chapter. After going through this chapter and this presentation in particular, students will be able to analyze the relationship between risk and risk premium, explain the different theories of term structure of interest rates, and later on deduce the relationship between the shape of yield curve with economic conditions. They would also be able to see different types of yield curves over certain time periods. So, what is premium? Premium is the difference between a given bond yield and another bond's yield. Now, risk premium is particularly the difference between a bond's yield and the risk-free bond's yield. There are two types of premium. The first one is risk premium, which is essentially the difference of the yields based on pure difference of riskiness of the two bonds. And the second is term risk, which is essentially all else constant, meaning same issuer over different maturities. So for example, if the 10-year bond issued by the government has a greater yield than the 1-year bond, again these are both terms to maturity, then the difference of the two yields is called the term premium. Sometimes term premiums can be negative as well. So different interest rates exist on bonds due to many reasons. One of them is default risk. So for example, how likely an organization is to cause a default. And by default what we mean is inability or lack of ability to pay back the coupons either on schedule or not at all. That is default risk. Government bonds within a country are assumed to have no default risk. The risk premium, therefore, is typically the difference between the yield on a bond and the yield on the government bond for the same term. So notice how here we've tried to keep everything else constant, but just compare the yields on the bond and the yield on government bond. Liquidity risk is because of the security or the bond having few buyers and sellers. So if there are fewer buyers and sellers, by the law of demand and supply, we will have less demand, meaning a lower price of the bond and higher yield. And that means since the yield is higher than the government bond, the differential for comparable term to maturity is called liquidity risk. Liquidity risk also comes with high transaction costs because it's not easy to find the corresponding buyer or seller. And then there are tax considerations. For example, in a municipal bond, there is no tax charged for the customer or the holder of that asset because of the payment of coupons to the holder. So what that means is, all else constant, treasuries which are supposed to offer a lower coupon will actually end up costing a little bit more to the investor than the municipal bonds. It makes municipal bonds more attractive, so more demanders for municipal bonds, all else constant, and therefore the price of municipal bonds is relatively higher, not higher than treasuries in the sense of lower yields, but the yield comparably drops if the price is higher, that is. So that is a tax consideration. No tax consideration makes the demand for a security higher, increasing its price and lowering its yield, therefore narrowing the risk premium between that bond and the government bond or treasury. So here is how to look at it. On the y-axis is price of a bond. On the x-axis is quantity of the bond. The line with increasing slope is a supply of bonds. The line with decreasing slope or negative slope, not decreasing slope, but negative slope, is a demand line. Now what happens is, as the risk increases, let's talk about the equilibrium before we talk about the risk. This particular combination of price and quantity is the equilibrium. In other words, here the number of bonds supplied and the number of bonds demanded at this price is equal. Now, if for certain reason a bond becomes more risky, demand for this bond shifts to the left. If the demand shifts to the left, the price of that bond goes down and the quantity demanded of the bond shifts to the left as well. So when the price goes down, yield goes up. To summarize, when the price falls, yield or the interest rate rises more than the risk-free rate, and this difference is called the risk premium. Now let's talk about the income tax considerations. If the interest rate is greater than the interest rate being offered on the treasury bond, under normal circumstances, now suddenly what happens is there is a declaration that this particular bond now is tax-free. In other words, the demand for this bond will rise. As the demand for this bond rises, price also rises, just the exact opposite of what we saw on the previous chart. If the price rises, yield falls, or interest rate on the bond, whichever is a tax-free bond, will go down, thereby narrowing the spread between the treasury bond and this particular bond. So this is called narrowing the spread or reduction of the premium between. Remember, this is still a more risky security than the treasury, but yet not as unattractive as it was before because of this lack of tax being charged on this particular bond. All right, now we're ready to define the term structure. So if the same issuer issues two different securities and these two securities differ in their term to maturity is the time between now and the time when the bond expires. So if these two bonds have different terms to maturity, they will essentially have different yields. It's very rare that two bonds with different terms to maturity will have the same yield. It is possible, it's not uncommon, but it's rare. This phenomenon of the differential spread between two bonds from the same issuer having different yields and observance of this particular phenomenon is called term structure of interest rates. And a relationship, the locus of all these points which correspond to a certain term to maturity and a certain interest rate or yield plotted on a line is called the yield curve. So yield curve is a relationship between the term structure of interest rates and the term to maturity. So this graphical representation of term structure is called the yield curve. Now let's look at the yield curve. So yield curve, well, it has a certain height or amplitude which corresponds to given yields of different bonds of different terms to maturity, and it has a certain shape, as we will see, and this shape can change with time, as we'll see with again some examples. So this change in shape essentially is differential of different yields or YTMs, and this differential of different yields will change with time. So if this differential goes up, we'll say the yield curve is steepening. On the other hand, if this differential goes down, the yield curve is flattening. Now, the inherent assumption, which is not again very correct, is that the yield curve has a positive slope. Again, not necessary, which means that bonds with higher terms to maturity in general will have a greater yield. So that is called the steep curve, as we're going to see now. So in this case, this is a relationship between yield on the y-axis and term to maturity on the x-axis. And this particular yield curve is flat, meaning no matter what the term to maturity is selected for this particular issuer government bonds, in this case, let's assume, the yield will be the same. So whether you choose a 3-year bond, 5-year bond, 10-year bond, 30-year bond, all have approximately the same yield. That's a flat yield curve. This is a ascending or a steep yield curve. As the time to maturity increases, the yield paid out on the bond will be greater. Finally, this is a descending or an inverted yield curve. In this case, what happens is short-term maturities of bonds will have a greater yield to maturity as compared to the long-term term to maturity bonds. And this is a humped yield curve in which initially the yield curve is steep and then it starts becoming flat and then inverts for very high time to maturities. We can see all of these kind of yield curves. Historically, this is an illustration between 1991 and 2011. The pink blocks are the yield curve in 1991. It's kind of flat-ish to steep, and then in 1996 it flattened just a touch, and then in 2001 the yields got lower on an average, but it steepened. In 2011, it got more steep and the yields on the short end actually went down to zero. And then in 2011, October, the yield curve steepened, flattened just a touch. So the long-term yield started declining as well. Now this is more recently. In 2010, you can see how steep. Now the scale is different. Here the scale is from 0 to 9, but here the scale is from 0 to only 5. So in 2010, from this yellow line, you can see how steep the yield curve was. In 2015, it became more flat. In 2018, still more flat. As you can see, the shorter end actually interest rates rose and kept rising until 2019, when the curve actually became flat. Moving on. Since 2019, so the red line now is 2019 June, the light blue line or violet line I think is December 2019. This is right at the cusp of COVID. See, the yield curve is still not completely flat. In fact, in June it was inverted, kind of at the lower end, and then steepened at the higher end. So inverse hump maybe. The orange line is in 2021. You can see how steep it is. So the red line is actually kind of precursor to the coming recession in 2020, and the white line actually is February of 2020. It is completely flat. So the red line actually was kind of giving some sort of a warning that there might be a recession in 2020. And then it steepened again, and the lower end went from 2.5% to 0%. So this is the trend of the yield curve. And then off late in between 2022 and 2022 it's slightly steep. In 2022 September, it became more flat. And the white line, 2023 January, it inverted. In fact, it inverted by a huge margin. Although the inversion might not be as, the differential or the spread is not as large. It's more flat. And in 2023 October, although it is still flat to inverted, the yields have risen significantly, like so. So in general, the yields of all treasury bonds have gone up thanks to the Fed's fight against inflation. So now let's talk about some theories of term structure. The first is pure expectations theory. In the pure expectations, well, the second one is segmented markets theory. The third one is liquidity premium theory. And the fourth one is the preferred habitat theory. We'll quickly go over the pure expectations theory in this presentation. And in the next presentation, we'll talk about the other theories. So let us talk about the yield on term security. So it is a geometric mean of the previous term and the future term securities. And that is the pure expectations theory. It's a function of what was and what is coming, and it's a mean of that. So these interest rates actually prevail over the life of that security. In other words, mathematically, now we have to define R1. Capital R1 is the interest rate for one period from today. Interest rate for one period for today. That is R1. And then on the left, if we say T plus 1, that means at the time T plus 1, R is rate for one period is the T plus 1 R1. That is the notation here. And then R2, rate today, this is 0 on the left for 2 periods. So rate today for 2 periods is R2. And the yield curve gives this relationship in the pure expectations theory of R1, T plus R1 and R2. The assumptions are you can substitute across different maturities. In other words, if you don't want to do a 2-period investment, you can actually exchange it for 1 period today and 1 period after 1 period from today, which gives us the same result. And we assume that the transaction cost of doing this so-called hopping between different periods is 0. So investors then can form expectations on future rates based on these R1 and R2 and invest according to that. So if we can look at an application of PE theory with respect to simple interest, it will look like this. So let's assume the rate today is 2%. So in other words, after 1 year, $100 at 2% will become $102. And then let's assume the 1 year rate available after 1 year. So R1 is 1 year rate, and then T plus 1 means after 1 period from today. So after 1 period from today, the 1 period rate is still 2%. So now we have $100 becoming $102 after 1 year, and then again 2% more of the $100. Remember, it's simple interest, it's not compounding. So 2% more of $100 is $2 more. So 102 plus 2 is 104. In other words, what is R2 now? What is the equivalent rate? That will give us $104. Well, $4 divided by 100 divided by 2 is 2%. So essentially 2% is R2. So R1 is 2, T plus 1 R1 is 2, and R2 is 2. Okay, now with compound interest, the pure expectations theory is this. If R1 is still 2%, that is, the rate today for 1 period is 2%. Then $100 will become 102. But remember, now this is compound interest. So if I say T plus R1, in other words, after 1 period from today, the 1 period rate is 2%, then the $102 will be reinvested at 2% more to give us 104.04. So what is R2 equivalent to? And to find that, essentially it's nothing but 104.04 equals 1 plus R to the power 2. And therefore 104.04 square root 104.04 divided by 100 square root minus 1 will be equal to R2, which comes out as 2%. So now with compound interest, if we have R1 is 2%, $100 will become 102 after 1 year. And if T plus R1 is now 3%, so 102 invested after 1 year will grow at a rate of 3%, which will be 3.06. So 105.06 will be the final amount. Now what is R2? It is 105.06 divided by the initial value 100, its square root minus 1. That will be 2.49%. So to give that illustration, let's just look at a calculator. So 105.06 minus 100, no, pardon me, 105.06 divided by 100. Now take the square root of this and minus 1 times 100. This will be the rate. If we use this, we will end up with the same amount. So divide by 100 will give us this, plus 1 will give us this, to the power 2 will give us this, times 100 will give us the future value, which is 105.06. So that is the significance of connecting R1, R2 and T plus R1 by the pure expectations theory. So concluding this will be that increasing interest rates make the yield curve steeper. And the second conclusion is that R2, the 2-period interest rate today, is the average of the 1-period interest rate today and the 1-period forward interest rate from 1 period from today. And let's end the discussion on part 1 of this. We do have a little bit more on pure expectations theory, but we'll continue that discussion in the next video.